Welcome back to the deep dive. Okay, so if you're working in heavy industry, maybe utilities, oil and gas, could be specialized manufacturing, you definitely know that air quality isn't just some environmental checkbox.
Right.
It's fundamental. It's safety. It's keeping operations running.
Absolutely. It's the lifeline.
Exactly. So today we're diving into something pretty specific. High-end industrial ventilation. We're looking at RAMFAN Defense Blowers.
Yeah, and these are, well, they're not your average shop fans, right?
Yeah.
Our sources show this gear was first engineered for really extreme demands. Think military defense operations.
Like on ships.
Exactly, like rapid smoke clearing on a Navy vessel. So our mission today is to figure out, okay, how does that kind of heavy-duty engineering actually help, say, a refinery manager or someone at a chemical plant?
What's the real advantage?
We need to get why this shift, from defense tech to heavy industry is kind of resetting the bar for what's considered essential safety equipment.
And the stakes, I mean, they're incredibly high, aren't they?
Oh, definitely.
Our sources really hammer this point home. If you're dealing with confined spaces, maybe flash fire risks, purging toxic fumes, there's just no room for error.
Yeah.
Zero. It's
Right.
this silent threat, as they call it. Affects liability, compliance, and obviously people's lives.
Fundamentally.
So it's about making sure your ventilation doesn't just, push air around. It needs controlled, reliable force.
Okay, let's talk performance first. When you hear defense grade, you immediately think, okay, this has got to be built for speed, for high output, right? Mission critical stuff. So what's the tech that makes these things so much more potent than standard gear?
Well, the big difference fundamentally is how they actually manage the airflow itself, the kinetics.
Okay.
Our sources point specifically to the TurboForce impellers. Now, forget the marketing talk about unleashing a hurricane.
Right, let's get practical.
Let's look at the physics. This impeller design, it generates much higher static pressure.
Okay, pressure. And it maintains consistent volume, the CFM, even when you've got long, complex runs of ducting attached, which you almost always do in these industrial settings.
So it doesn't just bog down when you add ducting.
Exactly. And that translates directly into faster air exchange, less time needed to clear a space.
Right, reduced exchange time.
Okay.
Okay, now I see where the ROI starts kicking in.
Yeah.
If your standard fan needs, say, half an hour to make a tank safe for entry, and this TurboForce thing does it in 15 minutes, well, you've just saved 15 minutes of labor cost. Multiply that by every single entry.
Precisely. And that power, that speed, it's absolutely critical when time is short and the hazards are high.
Sure.
Think about those real-world cases the sources mentioned, like pulling smoke out fast after a fire starts in a ship compartment.
Yeah.
Or industrially, maybe you need to quickly scrub methane from a huge underground utility vault before the crew can safely enter.
Right, you can't have them waiting around.
No. So this reliable, controllable power, that's why they're used across the board.
Right.
Industrial, fire services, marine, they don't just move air passively, they actively break down those dangerous air pockets, like dismantling an obstacle.
So that powerful airflow, high pressure,
Yeah.
it directly gives you a productivity advantage. Neutralize the hazards faster, fewer operational stops, crew gets more done. That's that relentless productivity the source talks about.
Okay, so moving that much air, that powerfully, especially in places where things might, explode.
Yeah, that immediately brings up durability and compliance, doesn't it?
Absolutely. This gear has to be engineered for, let's call it actual consequences. Meaning it has to survive things going wrong, not just operate perfectly under ideal conditions. Failure modes matter.
Right. So looking at how they're built, the sources talk a lot about the Lexan housing. Now, wait a minute, Lexan. That's a polymer, right? Not metal.
Yeah.
For a lot of people in heavy industry, the default thought is metal equals tough. So how do they justify using plastic, even high-impact plastic, in places with grit, drops, heat?
That's a fair question, and it comes up a lot. But the argument for Lexan, this specific type, is actually pretty compelling.
Okay, tell me.
Well, first off, weight. It's significantly lighter than a comparable metal housing. Easier to move around, deploy quickly.
Portability, okay.
Second, and this is crucial in potentially explosive areas, Lexan doesn't spark.
Good point. Drag a metal fan across concrete.
Exactly. Sparks fly. Not good around flammable vapors. Lexan avoids that risk entirely. And yes, it's designed to take a beating, those dings, drops, the everyday field abuse, and keep its shape and integrity way better than, say, cheap commodity plastic. but without the weight and sparking risk of certain metal housings.
Okay, that makes sense. Durability and safety combined, but toughness isn't enough on its own, right? You need proof it won't actually cause the ignition.
Precisely. And that leads us straight to certifications. That's the ultimate assurance. This is where having multiple certifications becomes strategically vital. RAMFAN units use motors that are UL SX ATEX certified as explosion-proof.
Okay, break that down. UL, ATEX, ISEX.
Right. So UL is the key standard for North America. ATEX is mandatory for the European Union. And ISEX is basically the international scheme that helps bridge global requirements.
So having all three
Means ironclad compliance, pretty much anywhere you operate. Whether you're in a classified hazardous location, Zone 1 or Class 1 Div 1 in Texas, or you're deploying a team for a project in the Middle East or Europe, you're covered.
And that's not just about dodging fines from regulators, which can be massive.
No, not at all.
This level of certified safety, especially for those really high-risk environments, it's serious liability protection, isn't it?
Absolutely critical. When a safety manager specs equipment with these kinds of layered, globally recognized certs, they're essentially shifting the burden. The manufacturer has certified it's safe for that environment.
So you're not just hoping it's safe.
You're backed by a certified guarantee. You're legally fortified, in a way. Ready for audits, ready for the worst-case scenario.
Okay, let's switch gears a bit. Talk about actually using this stuff on site. Modern industrial sites. They're not static, are they?
Not at all. Dynamic is the word.
Crews are constantly moving. One minute they're working near a flare stack. The next they're prepping for entry in some underground vault.
Right.
And dragging heavy, awkward ventilation gear around, that just kills efficiency.
Totally. It's a huge time sink and a physical strain. So that operational flexibility, it's not a nice to have, it's essential.
Yeah.
The sources emphasize these compact, durable designs because they're invaluable for on-the-go demands. You need gear that's less hassle, faster to set up, reduces that backbreaking work.
What's the biggest headache, usually, in those mobile scenarios? Is it power?
Often, yeah, power is a major constraint. If your job involved clearing air in a remote tank farm, maybe way out back.
Or deep inside a complex structure.
Exactly. Or just a confined space where running long, heavy-duty power cables is impractical or even hazardous itself. What do you do?
Right.
Well, that's where things like the high-capacity battery-powered ventilators really shine. They're game changers.
Battery-powered for this kind of airflow.
Yep. They provide what the sources call instant air support, perfect for those remote spots, or anywhere grid power is flaky, unavailable, or just where cable runs are a safety nightmare.
I can see that. Utility crews responding to an emergency outage, maybe.
Perfect example. Or a maintenance team working inside a boiler, far from convenient outlets. Battery power gives them independence. Their safety, their ability to get breathable air in, isn't dependent on the site's potentially compromised electrical system.
That kind of quick adaptation, being able to deploy anywhere, that's a real competitive edge, isn't it?
Massive. Think about organizations that juggle constant site changes. General contractors, defense support teams, major utilities. If they have portable gear that fits their standard operating procedures, their SOPs across all these different scenarios, it just simplifies everything. Less complexity, easier training, big win.
All right, let's put on the procurement hat for a minute. If you're the manager signing the checks for capital equipment, you're always walking that tightrope, right?
Always.
Get the best value, make sure it maximizes uptime, and critically ensure it meets all the compliance requirements. Absolutely watertight.
Yep.
Now, buying specialized defense-grade gear, there's often this perception, maybe reality, of a higher sticker price up front.
Sure, that perception exists.
So how does this kind of investment actually deliver better long-term ROI? Make the case.
Okay, the ROI comes from a couple of key angles. Standardization and ultimately lower total cost of ownership.
Yeah.
First, let's talk sourcing. How do you actually buy this stuff smartly? The trick is often using specialized, high-volume industrial suppliers. The sources mentioned peenergy.com as an example, places that focus specifically on defense-grade industrial supply.
Okay, so volume suppliers.
Yeah. By going through partners like that, procurement teams can often access wholesale pricing, even for this top-tier equipment. It makes it more achievable than you might think.
Gotcha. So access is part of it, but the strategic win isn't just the price tag itself. It's standardizing the fleet, right?
Exactly. That's the bigger picture. You might need different types of blowers for different tasks, forced air for just general confined space entry,
Okay.
explosion-proof models for tank cleaning where you've got flammable residues,
Right.
and maybe portable battery units for emergency response or remote jobs. Instead of buying 3 different brands, with 3 different sets of operating quirks, 3 different spare parts lists.
Oh, okay.
You standardize on one line, like RAMFAN, that offers that same high level of performance, durability, and certification across all those types.
So one vendor, simpler inventory, easier training.
Precisely. Fewer spare parts to stock, streamlined maintenance and support, and crucially, your crews only need to be experts on one system, not 3 or 4. It simplifies the whole safety logistics chain.
And if we tie that standardization and the durability we talked about earlier, the real payoff is reliability, isn't it?
That's the bottom line. Fewer breakdowns, less equipment failure,
Which means
fewer unplanned shutdowns. And that's where the money is. The sources are clear. Avoiding just one major production stoppage, just one incident where you have to halt operations because your ventilation failed, that can easily pay back the entire investment in upgrading your fleet.
yeah.
That cut in unplanned downtime, that's pure profit protection, pure money back to your bottom line. You're not just buying a fan, you're investing in operational resilience, assets that don't constantly fail.
Yeah.
So, yeah, to kind of wrap up the main points here, RAMFAN blowers really push the envelope on performance, mainly through those TurboForce impellers. You get real, measurable cuts in air exchange time.
Faster turnarounds.
Right. Then there's the safety and durability piece, the high-impact Lexan housing, plus those critical multi-certifications, UL, ATEX, ICE-XX. That gives you ironclad compliance, vital for global work and just covering your liability.
Peace of mind.
Definitely. And finally, there's strategic value, flexibility in how you deploy them, battery options, and the huge win of standardizing your safety gear through smart procurement, maybe using specialized suppliers.
It all ties together.
It does.
So as we finish up, let's circle back to that phrase from the beginning. The silent threat.
Mm-hmm.
The source material kind of throws down a challenge, doesn't it? It basically says waiting for a crisis, a big OSHA fine, a serious accident, maybe a total system failure during an emergency.
Yeah, waiting for the incident to justify the spend.
Right. Waiting for that moment to finally buy the better safety gear. That's just bad planning. Reactive, not proactive.
Poor strategy, yeah.
So it leaves us with a pretty sharp question for you, the listener. Thinking about your own operations, what critical safety investment, maybe like this advanced ventilation, are you currently putting off, delaying?
What's on the maybe later list?
What's on that list that, if you actually invested in it today, could turn a nagging vulnerability, a potential disaster waiting to happen, into a genuine strength, an ironclad competitive edge even?
That's the real question.
Because investing in that kind of absolute reliability, maybe that's the only true way to measure value in high-stakes environments.